Good day guys, I'm Joseph Obona, an electronics and PCB design engineer, and today we'll be learning about how to select the right resistor and capacitors in your electronics circuit. So when designing your circuit, there are so many factors to consider when selecting your resistor and your capacitor in order to have a well-functioning electronics device. So for the resistor consideration, we have the resistor value based on Ohm's law and the application requirement. This is very important. When selecting your resistor, you ought to know the proper resistor value. Let's say you're working with an I2C protocol that needs a pull-up resistor. You can either use your 4.7K or 10K ohms resistor you get. So selecting the proper value in terms of that application is very critical and necessary in order to have a well-functioning circuit. So number 2 for resistors, we have power rating. 0.125 watts, 0.25 watts, and so on. Make sure to derate by 50 to 70% for reliability. When selecting your resistor, you need to calculate the power moving through that particular line so that you can select the resistor that has the appropriate power rating. If the power moving through a particular line is about 1 watt of power, and you select a resistor of 0.5 watt of power, you will actually cause damage in your circuit. Your circuit can blow up or you have a short circuit. So that is why it's very important to calculate all this. So number 3, in terms of resistor selection, you have a tolerance level. You have plus or minus 1%, you have plus or minus 5%, plus or minus 10%. So in terms of when you're using plus or minus 1%, those are for very precise precision circuits and we have like plus or minus 5%, plus or minus 10%. You can use it in normal general based circuit, which will work appropriately. When designing some electronic device, in the data sheet of the component or the component you're using or data sheet of the manufacturer, they might tell you to use a resistor value of plus or minus 1% based on easy precision circuit. So do not forget that, it's very important. Heading forward to number 2, we have our capacitor. We still have our capacitor value. You ought to know the value of the capacitor you're using in that particular section of the circuit. Depends on the application, either filtering, timing, or decoupling. You can use capacitors for so many things, for filtering circuit, for timing circuit, and also decoupling circuit. In terms of when we're using capacitors for our filtering circuit using our microcontroller and our power sections and our power pin, it's always appropriate. Most times by default we use 0.1 microfarad capacitors, and on the data sheets of the components also, the manufacturer will specify the values of capacitors you ought to use to actually get a well-functioning circuit. So number 2 I have here for capacitors, also the voltage rating. The voltage rating of the capacitor is very critical and important. If your circuit voltage is running on, let's say, 12 volts and you use a capacitor or voltage rating about 12 volts T, this is not very sufficient. It might actually withstand the voltage capacity, but within the long run your capacitor might get damaged. So it's always good to use a value higher than the actual circuit value. So if you have a circuit value of 12 volts while selecting a capacitor, it's appropriate to use 24 volts and above. Though you can still use 15 volts, but I normally recommend 2x. Then we have our ESR, which is called equivalent series resistance. Critical for power supply circuits. This is critical for power supply circuits. Then we'll have the last one, which is package type. We have our SMD and through-hole package. So when doing your capacitor, when designing your circuit, you ought to know if you use that particular component as an SMD component or as a through-hole component. Thank you guys for today's class. Subscribe, like, and share.